Hello all. Welcome to the section 5.4 lecture video. So we're going to pick off where we left off last time, talking about the definite integral. So you can go ahead and take out your handouts and open to section 5.4, which is on page 23, and we're going to start talking about the fundamental theorem of calculus. So the fundamental theorem of calculus has to do with the idea of how basically do we find definite integrals. So there's a few theorems that are really important to us here. So first of all, is the mean value theorem. So the mean value theorem is simply how do we find a mean value, and the way you do that is you find the definite integral, which is what this notation stands for, right? And then you multiply it by 1 over the width of the interval, or in other words, you divide by the width of the interval, how big the interval is, 1 over b minus a. And then the fundamental theorem of calculus will help us do this more simply because it'll help us do the definite integral easier. So the fundamental theorem of calculus says if f is continuous on a comma b, the interval from a to b, then the antiderivative of f of x is equal to a to x of f of t dt is continuous on a comma b and differentiable on a comma b, and its derivative f of x is the derivative of the antiderivative is equal to the derivative of the function from a to x of f of t dt, which is simply the function f of x. So what this means for us is if f is continuous over a comma b and f is the antiderivative of f on a comma b, then the definite integral of from a to b of f of x is simply the antiderivative of b minus the antiderivative at f. Okay. So for example, if I wanted to find the definite integral from negative square root of 3 to square root of 3 of t plus 1 times t squared plus 4 equals dt, what I want to do is I want to find the antiderivative of this function first, and then I want to plug in the values, plug in each value. So let's go ahead and take a look at that and the notation we're going to use for that. So in this case, one of the things remember you want to deal with is we don't have a rule for doing antiderivatives of products. So one thing we probably want to do before we do the antiderivative is find each of these functions, multiply this back out. So this will be the definite integral from negative square root of 3 to square root of 3, and then I'll multiply t plus 1 times t squared plus 4, so that's t cubed plus t squared plus 4t plus 4 dt. Okay, and now what we want to do is we want to find the antiderivative of this function. Okay, so we can do that. So the antiderivative of t cubed is t to the 4th over 4, right? I add 1 to the exponent and then divide by that new exponent. Plus the antiderivative of t squared is t to the 3rd over 3. The antiderivative of 4t is 4t squared over 2. And the antiderivative of 4 is 4t. And then we put a vertical line and we put where we're starting and where we're ending. So negative square root of 3 to square root of 3. And so we now just plug each one of those values into the function and find the difference between them. So this will be the square root of 3 to the 4th over 4 plus the square root of 3 to the 3rd over 3 plus 4. I'll just go ahead and simplify that. 4 divided by 2 is 2. So 2 times the square root of 3 squared plus 4 times the square root of 3. So that's capital F, the antiderivative at B, minus the antiderivative at A. So that's going to be the negative square root of 3 to the 4th over 4 plus the negative square root of 3 cubed over 3 plus 2 times the negative square root of 3 squared plus 4 times the negative square root of 3. Okay, and so now we can simplify all those. So square root of 3 to the 4th is 9, so this will be 9 over 4. Square root of 3 to the 3rd is 3 root 3 over 3. Square root of 3 squared is 3. And then over here we get negative square root of 3 to the fourth is 9, so this is 9 over 4. Negative square root of 3 to the third is negative 3 root 3 over 3. Negative root 3 squared is 3, and 4 times negative root 3 is 4 negative root 3. Okay, so now we can combine like terms and see what we get. So here we get, well, here, I'll go ahead and write it out again. So let's simplify these. So 9/4 plus root 3 plus 6 plus 4 root 3 minus 9/4 plus root 3, right? Because it's a negative and a negative, right? We've got the negative here and the negative here, so that becomes positive. Then 6 becomes negative 6, and negative 4 root 3 becomes positive 4 root 3. And then we combine like terms. So 9/4 cancels with negative 9/4, 6 cancels with negative 6, and now I've got root 3 plus 4 root 3 plus root 3 plus 4 root 3 is 10 root 3. Okay, because I've got 1 root 3 plus 4 root 3 is 5 root 3 plus another root 3 is 6 root 3s plus 4 more root 3s is 10 root 3. And so there is the definite integral of this function. So finding definite integrals really is just going to be about finding antiderivatives and then plugging values into that antiderivative. So let's try another one. So once again, we don't have a rule for dealing with division, so I can simplify this. So this will be the definite integral from -1 to 1 of y to the fifth over y to the third minus 2y over y to the third dy. And then I simplify that again, and that's -1 to 1 of y squared minus 2 over y squared dy. And probably to make this even easier to do the antiderivatives, we could do, this is from -1 to 1 of y squared minus 2y to the negative second dy. Okay, so now we do the antiderivative. So the antiderivative of y squared, remember what we're doing is we're adding 1 to the exponent and then dividing by that number. So this will be y cubed over 3 minus 2y to the negative first over -1. And then we're doing this from -1 to 1. So those are the two numbers we're going to plug in. So simplify. And this is y cubed over 3 plus 2 over y from -1 to 1. Okay, and so now we can plug those two values in. So this will be 1 cubed over 3 plus 2 over 1 minus -1 cubed over 3 plus 2 over -1, and we can just simplify. So that, and if you wanted to, for this one especially, because you don't have any radicals, you could just plug this in your calculator and see what you get. The one before, we kind of had to do it by hand because we had square roots involved, but this one you could easily plug in your calculator. So this would be 1/3 plus 2 minus -1/3 minus 2. All right, if I simplify, distribute the negative, so this is 1/3 plus 2 plus 1/3 plus 2. And then if we add those all together, we get 2/3 plus 4. So that's going to be 14/3. Okay, so that's the value of the definite integral. Okay, so that's what we're looking for here. So what I'd like y'all to do now, is go ahead and flip over to the next page and try doing these three here. So go ahead and pause the video for a second and try these three. Once again, making sure you simplify things before you go do them. Okay, so now that you've had a chance to try these, hopefully you all were able to do at least the bottom two here without too much trouble. But then the first two may take a little more for work for us. So the first thing you want to do is simplify this a little bit, right? Because we don't have division. And so what you want to do is rewrite this using what we know about trig functions. So this would be the definite integral from 0 to pi over 3 of 4 times sine u over cosine u times 1 over cosine u. Okay, that's the same thing, just another way to write that. And now we can simplify these. So this is 0 to pi over 4 of 4 tangent u secant u du. Okay, and now we can do the antiderivative of that. The antiderivative of tangent u secant u is secant u, right? So this would be 4 secant u from 0 to pi over 3. Okay, and so that's going to be 4 secant pi over 3 minus 4 secant of 0. And you could try putting that in your calculator if you wanted to and see what you get first. That's never a bad way to start with these. And if you get a decimal that you don't know, you're probably going to have to do it by hand. When you do, if you do try and put this in your calculator, just make sure that you're in radians. Okay, so I'll go ahead and do it on the calculator here. So if we open our Class Calc app and we go to the scientific calculator, we can put in 4 secant of pi divided by 3, pi divided by 3 minus 4 secant of 0. And one thing you all may be noticing here is that I did get a decimal, but there's actually a reason I'm getting a decimal when I might actually expect to get a whole number answer here, which is my calculator was not in radians. So I click degrees at the top, hit that little toggle switch there to change it to radians, and I get 4. Okay, so this definite integral is 4. Okay, so that's the idea. Like I said, the other two are a little bit easier here. So this one, we just do the antiderivative, right? These are easier ones to do the antiderivative. So this is the antiderivative of x to the third is x to the fourth over 4. The antiderivative of 2x is 2x squared over 2. And the antiderivative of 3 is 3x from negative 2 to 3. And so this will be 3 to the fourth over 4 minus 3 squared plus 3 times 3 minus negative 2 to the fourth over 4 minus negative 2 squared plus 3 times negative 2. Okay, so that's 81 over 4 minus 9 plus 9 minus 4 minus 4 minus 6. Okay, and then we can distribute the negative and combine like terms. So negative 9 and positive 9 cancel, negative 4 and positive 4 cancel, and we add 81 over 4 to 6. So that's 81 over 4 added to 24 over 4, so that's 105 over 4. And once again, really, once you've done the derivatives, you could plug this in your calculator, and it would do the rest of it for you. Okay, so then the last one here, same idea. We can do the antiderivative. The antiderivative of 1 is x. The antiderivative of cosine is sine of x from 0 to pi. And so then we plug those numbers in. So this is pi plus sine of pi minus 0 plus sine of 0. So that's pi plus 0 minus 0 minus 0. And so this is just pi. Okay. And so that's the idea. Okay, so at this point, we're going to go ahead and skip over page 25 here. It's not something you really need right now to know how to do. And since we're coming to the end of the semester, I don't want to focus too much on things that you don't need moving forward in this class and in the next class. So let's go ahead and skip ahead to the last page in this section and talk about finding total areas. So first of all, we have this theorem, which is important, which is the net change in a differentiable function f of x over an interval a to b is the integral of the rate of change. So just remember that rate of change is simply the derivative. So if you do the integral of a derivative, you get the net change over an interval. But what we really want to focus on is finding total areas. So one of the things that runs into when you're doing definite integrals is if this is, let's say, this is my graph, and then here's my function. I want to do the definite integral from here to here. Okay, here's my a, and here's my b. What happens is, in this area and this area, I get a positive value for the area. But down here, below the x-axis, I get a negative value for the area. So when I add all three of those, if I just do the regular definite integral, part of the function is canceling itself out. So I'm not getting the total area. So to find the total area, what I have to do is break this into pieces based on where the zeros are, and then do 3 definite integrals and add them together. So that's the idea we're going to look at here. So to find the area between the graph of y equals f of x and the x-axis over the interval a comma b, subdivide a comma b at the zeros of f. Integrate f over each subinterval. Add the absolute value of the integrals. Okay? So you can do this in a couple different ways, but let's just go ahead and graph this first function, and we can look at it. So the first one we're looking at here, if I go to my graphing function, is x to the 1/3 power minus x. Okay, so it looks like this. And it actually doesn't look exactly like this, but we'll talk about that in a second. This is one example where our graph is not working out exactly great in this function here. Okay, so if we look at this graph, it'll actually tell me where the other 0 is, even though I don't have it marked here. But notice that I have zeros at -1, 0, and 1. And I'm looking at the interval for this problem from -1 to 8. Okay? So if I zoom out a little bit, that's the part I'm looking at. So what I want to do here is break it up, our region up at each one of these zeros. So my zeros are -1, 0, and 1. Okay, so back in the problem. Our zeros from the graph, and you could find it by setting the equation equal to 0 and solving for x as well. But we just did it from the graph. We're at -1, 0, and 1. So I want to break up my interval, which is currently -1 to 8, at these zeros. So now my intervals are going to be -1 to 0, 0 to 1, and 1 to 8. Okay? So what I could start out by doing is I could start out by finding f and then use this idea. So what I could do is I could find f by doing the antiderivative x to the 1/3 power minus x. So the f we're going to use here. Okay, dx. So we could find that. So add 1 to the exponent. So this would be x to the 4/3 over 4/3 minus x squared over 2. And so that's 3x to the 4/3 over 4 minus x squared over 2. And now we just need to find, so that is my antiderivative. And so to find the definite integral for each one of these regions, I just find the value of the antiderivative over these regions. So that's going to be 3x to the 4/3 over 4 minus x squared over 2 from -1 to 0. 3x to the 4/3 over 4 minus x squared over 2 from 0 to 1. And 3x to the 4/3 over 4 minus x squared over 2 from 1 to 8. Okay, and you could, this would be a good point to use your calculator if you want, but I'm going to write out what I'm going to do. So I'm going to use the definite integral formula. So this would be 3 times 0 to the 4/3 over 4 minus 0 squared over 2 minus 3 times -1 to the 4/3 over 4 minus -1 squared over 2. And we'll get a value for that. The second one will be 3 times 1 to the 4/3 over 4 minus 1 squared over 2 minus 3 times 0 to the 4/3 over 4 minus 0 squared over 2. And then the last one is 3 times 8 to the 4/3 over 4 minus 8 squared over 2 minus 3 times 1 to the 4/3 over 4 minus 1 squared over 2. Okay. So let's see. What are we going to get for those? Well, let's just go ahead and we can plug that in our calculator now. So go back to the scientific calculator, and this is parenthesis 3 times 0 to the 4 divided by 3 over 4 minus 0 squared over 2 minus the same thing but with -1s where the zeros are. So 3 times -1 to the 4 divided by 3 over 4 minus -1 squared over 2. Close parentheses. Okay, so the first one, we're getting -1/4. And then if I do the same thing, but I'm just going to replace these values so that the zeros become 1s. The -1s become 0s. Okay, so that's +1/4. Now notice, if I just added those together normally, they would cancel each other out, which is the problem we have with doing finding areas by simply finding the definite integral. And then if I do the same thing again, but this time I have an 8 here and an 8 here, a 1 here, and a 1 here, then I get -81/4. Okay, so we've got -1/4, 1/4, and -81/4. And notice the regions that were below the x-axis get us negatives. So notice now we're going to add the absolute values. So I'm going to add, to find the area, I'm going to add 1/4 plus 1/4 plus 81/4, which is 83/4. And so there is the total area in that region. Okay. So to finish off this video, let's just go and try one more of these. That'll be, I think the graph for this one will be a little better, so it'll be a little easier to see what's going on. So if I graph 3x squared minus 2, minus 3, sorry. Minus 3 from, let's set our domain, -2 to 2. Why isn't that working? Oh, no, there it is. Okay. So we get a region that looks like this. So the important part for us is that the zeros are at -1 and 1. So we get 3 regions again. So we're going to have these 2 regions that are above the x-axis, and then we're going to have this part that's below. So our zeros in this case for the second one are at -1 and 1. So that means if I take my region from -2 to 2 and break it up into pieces by those, I'd get -2 to -1, -1 to 1, and 1 to 2. Okay, so those are the 3 regions I need to find the antiderivative over. So start by finding the definite integral over. Start by finding the antiderivative of this function. So the antiderivative of this is 3x cubed over 3 minus 3x, which is x cubed minus 3x. So then we're just going to find x cubed minus 3x from -2 to -1, x cubed minus 3x from -1 to 1, and x cubed minus 3x from 1 to 2. Okay, and once again, using the calculator is probably the best way to go about this, but I'll go ahead and write out first what I'm going to put in the calculator. So this will be -1 cubed minus 3 times -1 minus -2 cubed minus 3 times -2. This one's going to be 1 cubed minus 3 times 1 minus -1 cubed minus 3 times -1. And the last one will be 2 cubed minus 3 times 2 minus 1 cubed minus 3 times 1. And once again, we'll be able to use ClassCalc to find those fairly quickly and easily, just like we did on the previous problem. Okay, so let's give this a try. So let's go back to our scientific calculator, and we can put in our functions. So the first one is -1 cubed minus 3 times -1 minus -2 cubed minus 3 times -2. Okay, so that's 4. And then we can take the same thing and just plug in our next set of values. So the next region was 1 and -1. So for that one, we get -4. And then for the last one, we get 4. Okay, so 4, -4, 4, and then you can add the absolute values together to get the total area. So 4 plus 4 plus 4 is 12. And notice this is another example where part of this answer would have canceled out the other part. So it's a good, that's how we needed to use the absolute values. So that's it for section 5.4. Make sure you're doing your homework assignments on my math lab, and feel free to call, text, or email me if you have questions about anything from this video or anything else for the class.